graph. So we saw this one only went up to 4. We saw this one went up to 8. So it could get you a little bit better here. These guys represent a fairly normal curve. This one you can consider maybe close to normal, maybe a little tiny bit skew at the other side, at the left side. So just match them up by their ends. 4 and 8. Okay. This was using your 3 formulas. Sometimes when we have a large amount, we don't want to make a table of all your probabilities and put it in your L1, L2. We want to default to your formulas. And so for you guys that learn here, and this would be you two, mean, variance, and the standard deviation is the square root of it. So, and the mean makes sense if you think about it. Your probability is like a percentage of things you expect to happen, a trending, a forecasting. What's your chances of something happening? If you're going to say, how many people do I expect out of 400 to answer yes, you're going to look at your trend. If 20% of your trend answered yes, you're going to expect 20% of your population to answer yes. So that makes sense that the mean comes from n times p, right? N times the percentage, which is your probability. Your variance we have to find first, and then we have to take your square root. Everybody okay with those? Well, you have to know those formulas. But it's kind of easy. The n times p is kind of easy, and then times it by q. It's the only variable left. So it's an easy way to remember it. 11, 12, 16, and 19 we did. Okay, for these guys, again, you had to construct a binomial distribution. Binomial says 4 things have to happen. Chance of success, chance of failure, fixed number of trials, probabilities do not change, and x is your random variable representing all possible outcomes. Okay, a binomial PDF still incorporates what our PDF does because it's called the binomial PDF. The PDF part is your probability distribution function, which says these guys are between 0 and 1, and the sum of this is 1. That's why we call this a binomial PDF, just so that you know the difference between them. So 67% of adults 55 and older want to reach their 100th birthday. You randomly select 7 adults, this is your N, and you ask them if they want to reach their 100th birthday. They say yes, they say no. Success, failure. So 67% is our P, 1 minus 67% is your Q, and if you put this in your binomial PDF, it's N, P, X. N is your trials, 7, probability of success, and start from 0 and go to 7. Remember, be careful if they set this in scientific notation. Your probabilities can never be greater than 1. So if you have one of those little E's out there, if something is really small to happen, if you have an E out there, make sure you move your decimal place. Okay, and again, since our probability is greater than 0.5, we expect our larger numbers to be here with more people saying yes, because the chance of them saying yes is greater than half. So we expect our larger bars to be here, therefore we expect a skew to the left. Do you see how that fits into each other? It's almost like common sense that you expect that to happen. If it's a higher probability, more people will say yes. Don't forget to give it a title. Your y-axis is your probability, and your x, where's where all your bars go. Good? Alright, we had 24, kind of the same thing, same setup, but now our probability was 0.38, which means I don't have that strong of a chance for someone to say, yes, I agree. So now, your bars are going to be a little higher to the front rather than the back. So we're going to be skewed to the right. Follow the little tail. And if it wasn't for these guys, we almost would be normal. But see where your tail trails off? Your tail trails off right here. Because we didn't expect a lot of people to say yes since your probability wasn't a very strong probability. Managers who have a negative view of messy desks. Okay. Be careful because even though they have a negative view, that is the success you're measuring. You're measuring the success based on your scenario, not based on what you think is a good thing. Having a negative view, having a positive view, that has no bearing on success and failure. It's whatever the situation states. Like, I remember the Algebra 2 Regents, one of the biggest things was rainy days versus not rainy days. And whenever they throw that not in there, it would confuse kids on how many not, that's not good to have a rainy day. I'd rather not have a rainy day, you know. So you just got to make sure your success is what your situation is looking for. Find the mean, the variance, and the standard deviation. Again, n was not that big here, 4. You could make a table if you wanted to, but if, God bless you, we proved yesterday that the table and this works the same. Your L1, L2 works the same as this. So we can use these formulas, and your mean tells us the average. The average is 2.8 out of 4 adults think that musicians should be allowed to sing potentially offensive songs. 2.8, I don't have really 2.8 of these people, but don't forget, when you do your class averages, you can get 85.23, and you don't have 0.23 of a grade. So that's just on the average, leaning towards the 3, almost 3 out of 4 people. And if you think about it, 69% is close to 75, which is 3 out of 4 people, right? Try to make sense out of these things. Was everybody okay with this? These are the formulas that you missed. And the last one, same kind of situation. 39% of adults think that life existed on Mars at some point in time. You surveyed 6 adults. We could easily make a table, 0 through 6. But why bother if all they want to know is the mean, the standard deviation, and the variance? Are we good with this? Not a lot. It's kind of, the same thing over and over.